3, 2, 1. We have ignition and liftoff of the United Launch Alliance Atlas V rocket.
Go Atlas. Move Centaur. Go Kuiper.
Good morning, and welcome to live coverage of ULA's Atlas V launch of the third batch of Project Kuiper satellites for Amazon. I'm Britt Porcelli, and I'm a propulsion engineer here at ULA, and I'm joined today by Ryan Schleter, an electrical engineer.
We're joining you from ULA's Advanced Spaceflight Operations Center here at Cape Canaveral Space Force Station in Florida. We also have team members on console at ULA headquarters in Denver, Colorado. Liftoff is scheduled for 8:09:30 a.m. Eastern Time at the opening of today's 29-minute launch window.
Launch windows vary by mission and are determined by the payload's destination. Today's mission is going to low Earth orbit, or LEO as we refer to it, and has multiple orbit insertion opportunities.
We'll be covering today's mission through the start of the second stage engine burn. For additional real-time mission coverage, follow along with our live blog at ulalaunch.com. And if you enjoy watching our live broadcasts, don't forget to subscribe to our YouTube channel for access to future missions, launch highlights, and behind-the-scenes rocket content.
At this time, the team is not working any issues, and we're proceeding towards an 8:09:30 a.m. liftoff. All right, we're taking a live look of the mighty Atlas V sitting on the pad. I always love an early morning launch here. We're right after sunrise, where we're getting that early morning sun coming in, and we are in store for a pretty good launch today.
Yeah, the sunrise this morning looked beautiful, and Atlas there, it looks like we got pretty clear skies. Atlas sitting on the pad today is about 205 feet tall. This is the 551 configuration for a 5-meter fairing, 5 SRBs, and 1 RL-10 engine.
Yeah, and our payload fairing sitting at 77 feet total in length. You nicely have all 27 Kuiper satellites tucked away, and we should be in for a good launch today and great orbital insertion. As the countdown continues, our team is taking the final steps in preparation for liftoff. The first stage, also known as the rocket's booster stage, is a large tank on the bottom that is actually 2 tanks. One is filled up with RP-1 fuel, and the other with liquid oxygen. Liquid oxygen is the super cold cryogenic propellant that turns the tank's exterior from a bronze to a frosty white as we progress through this broadcast.
Atlas is also equipped with a Centaur upper stage, which drives the payload during the second phase of flight to its final orbital destination in space. The payload fairing, or PLF, completes the rocket and provides the aerodynamic shape necessary for the climb to space. On the upper stage and PLF, we see logos for Amazon, Atlas, and ULA, as well as the American flag. Let's learn more about how ULA builds the Atlas V rocket.
Engineered in Centennial, Colorado, ULA's Atlas V rocket is built in Decatur, Alabama, and launched from Cape Canaveral, Florida. Once the rocket is manufactured, it travels to Cape Canaveral on ULA's cargo ship, known as Rocket Ship. After arriving in Florida, ULA's launch operations team begins assembling the rocket. Stacking begins with lifting the 107-foot Atlas booster, powered by an RD-180 engine, onto the mobile launch platform. For Amazon missions, 5 solid rocket boosters are attached to the sides of the first stage for additional thrust at liftoff. ULA's ultra-thin stainless steel Centaur upper stage, powered by an RL-10 engine, is then lifted into position. Lastly, the payload fairing, containing the spacecraft, is lifted and mated to the Atlas V rocket. Once assembled, the countdown begins with moving the rocket from the vertical integration facility to the launch pad. The trip to the pad is about 1/3 of a mile. Throughout the 20-minute trip, a payload van leads the move, providing communication with the spacecraft, followed by the ground van providing support to the rocket. The mobile launch platform supplies air conditioning, electrical, and propellant lines to the rocket. Track mobiles at the rear power the convoy, which includes an environmental control system providing air conditioning to the payload and rocket, as well as a backup generator. Atlas arrives at the pad for fueling and other final preparations, and once fueled, weighs nearly 1.3 million pounds and stands 205 feet tall.
Today's mission will deliver another 27 of Amazon's Kuiper satellites to orbit. Let's learn more about Amazon's Project Kuiper and what they've been doing to prepare for offering internet connectivity from space.
It all starts with a countdown. But a countdown to what exactly? 6 years ago, we took on a journey to build the most advanced and the most modern communication system in the world. There are almost 3 billion people that don't have high-speed connectivity. Imagine if they had the ability to be connected just like you and I do, what they could do, what contributions they could make.
This mission is ambitious for a truly worthy cause. It's going to impact communities that cannot be reached with fiber traditional communications. The solution really has to be from space.
You can think of Project Kuiper as a three-part system: the satellite constellation, the customer terminal, and just as critically, the ground network and software that ultimately deliver connectivity. We have set out to design the most advanced satellite network ever built, and we have created the whole thing in-house at Amazon. You need just about every technology area to contribute to build the satellite: the propulsion system, the solar arrays, the silicon, the phased array antennas, the optical inter-satellite links.
The team has to be innovative, agile, resilient as we're moving very, very fast. Building, testing, developing in-house has been an extraordinary ingredient.
When we first proposed Project Kuiper internally, one of the first questions was, can you produce an affordable customer terminal? We knew that was going to be the linchpin of our system.
The big breakthrough for us was combining transmit and receive antennas into a single aperture. No one had ever done this in the Ka band. That let us pack a ton of performance into a really compact, really low-cost design. We're going to build tens of millions of these antennas, and we are well on our way. The design is done. We're now in the factory manufacturing it.
We talk about the satellites in constellation, but Kuiper is a satellite constellation being operated as a network across hundreds of ground gateway terminals.
Our ground network is spread out all over the world, and each site connects back to AWS. We already have a bunch of these sites installed everywhere from Australia to Germany, and more of them are coming online every month.
There's a big difference between launching 2 satellites and launching 3,000 satellites.
The past couple of years, my team has really been focused on how to achieve scale. Our own dedicated payload processing facility gives us the ability to control our own destiny. We've got the capacity to integrate up to 5 satellites per day and launch 3 simultaneous campaigns. Heavy lift rockets have higher performance, so we can take more satellites to orbit on any given launch. All of our heavy lift launch partners have had a successful first flight, so that's been a pretty exciting thing for us to see because we made those investments years in advance.
All of the pieces have come together to support that first launch, and the next one, and the one after that. It might not all go perfectly, but we have an incredible commitment to this project and an incredible team committed to its mission. All roads lead here, a countdown to launch. And with more than 80 missions planned, we're just getting started.
Today's launch is supported by teams both local here at Cape Canaveral Space Force Station in Florida, as well as back at ULA headquarters in Denver, Colorado. Over the summer, however, our team is bolstered by approximately 100 interns, representing schools all over the country, across 17 disciplines, at all 6 ULA locations.
Our intern program is a great opportunity to come in and see what it is in the day of the life of a ULA rocket scientist. And the intern opportunity comes with other opportunities as well. Ryan here is actually a part of our intern rocket program, which is one of the ones that we offer.
Yeah, every year our interns will build high-power rockets. In recent years, they've been as tall as 20 feet, and in years past, they've been as tall as 50 feet. which is crazy to think that's a quarter the size of the full-size Atlas we have sitting on the pad. And after we build those rockets, we'll integrate payloads that are built by K-12 students. We have a whole simulated launch campaign with payload integration, day of launch. We have the launch itself, deploy the payloads, and then they'll go do their own science.
If you're interested in this opportunity, intern application window is right now open until December. So go online, see if you qualify, and apply because we need more rocket scientists out here.
Definitely. And if you are a K-12 student or a K-12 educator, and if you're interested in flying a payload with us, we'll have more information coming out around the new year. You can visit the internships page or the intern launch page on ulalaunch.com to learn more.
As we get closer to the opening of our launch window, let's have a look at the weather forecast our launch team just received from Delta 45 Weather Officer Jimmy Tager. Today's launch forecast is looking good, with the probability of violating launch constraints at a minimal 5%, ground winds from 4 to 8 knots coming out of the southwest, and the temperature is approximately 78 degrees Fahrenheit. The primary concern for today's launch is violating the cumulus cloud rule.
LC switch is ready. All steps are complete prior to the status check.
Once we lift off, viewers watching the launch from Florida and from points in the Northeast may be able to see Atlas in flight. To get a closer look at this visibility map, check out @ULA-Launch on social media.
L minus 8 minutes.
We remain in the planned 30-minute hold as we continue towards liftoff. In a few moments, ULA launch conductor Dylan Rice will pull the team for the final go to pick up the countdown. The launch conductor manages the launch team during countdown, ensuring that all systems are performing nominally and that every member of the team is following their procedure and executing to the preferred timeline.
28 engineers are pulled to confirm the rocket is ready to proceed. This is the final status check for all Atlas vehicle systems, ground systems, the payload, and the U.S. Space Force Eastern Range. Let's listen in as he performs the pull.
L minus 7 minutes. Status check to proceed with terminal count. Atlas systems. Propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems. Propulsion. Go. Pneumatics. Go. LO2. Go. LH2.
Go.
As-gas. Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Op support.
Go.
COM.
Go.
Umbilical.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range and weather.
Go.
Launch director.
You have permission to launch.
Proceeding with the count. ALC verify T0 is set for 12:09:30 Zulu.
Verified.
Polling is complete and the team is go for launch. From now until liftoff, launch conductor Dylan Rice and the launch team will continue reporting the final steps in today's countdown.
This includes verifying propellant levels and pressures in the booster and Centaur fuel tanks, as well as arming the ordnance for ignition, separation, and flight termination.
At T-minus 1 minute, the range confirms that it is in green condition for launch, assuring that there are no nearby constraints like boats, planes, or weather, and that all systems are tracking operationally. At T-minus 25 seconds, you'll hear, "Go Atlas, go Centaur, go Kuiper." This is the final status check for the rocket and payload.
To dampen the acoustic shock at liftoff, At T-minus 6 seconds, the launch pad's water deluge system activates, followed a few seconds later by booster engine ignition. Then, after seeing Atlas lift off, you'll hear flight commentator Sarah Bailey Glasgow providing updates as the rocket ascends into space.
So as we're nearing to the end of our countdown, you can tell that there's excitement here in the LCC and all of our console rooms. As we're getting excited, though, the engineers are staying focused, looking at their data, because we know we got the A-team behind us working for today's launch.
Yeah, that's a good way to put it. It's a calm excitement. Everything's been proceeding as we expect, which is always good to hear.
Yeah, and I've been on console for a couple of launches in the past, but today is a special one because it's Ryan's first launch here at the Cape in person. So we definitely have a great thing in store for today. This is Atlas Mission Control at T-minus 4 minutes and 10 seconds. We anticipate releasing the hold in just a few moments.
T-minus 4 minutes and counting. 3, 2, 1, mark.
The countdown clock has resumed, and we are go for launch at 8:09:30 a.m. Eastern Time.
After liftoff, ULA's Atlas V rocket will fly northeast from Space Launch Complex 41. Here's a look at today's flight.
Following final confirmation of rocket readiness, the RD-180 engine and 5 GEM 63 solid rocket boosters ignite to produce more than 2 million pounds of thrust, lifting ULA's Atlas V rocket away from the pad. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path while minimizing the dynamic pressure it experiences during flight. Atlas then reaches Mach 1, the speed of sound. The addition of 5 solid rocket boosters, or SRBs, precisely augment the liftoff thrust of the Atlas V, giving it the power to deliver the payload to orbit. With their propellant expired approximately 96 seconds into ascent, the SRBs burn out, followed by jettison. Atlas's guidance system then begins steering towards the precise target in space. Amazon's Kuiper satellites are encapsulated inside a 5-meter diameter payload fairing, which provides protection to the spacecraft during ascent. After crossing the Kármán line, entering space, the payload fairing is jettisoned. With the majority of propellant expended fighting against the force of gravity, the RD-180 engine shuts down and the booster stage separates. The rocket then begins second stage flight, weighing less than 7% of what it did at liftoff. ULA's high-performance Centaur, with its RL-10 engine, ignites, powering the upper stage and spacecraft into a circular low Earth orbit. The first burn comes to an end with engine shutdown, followed by Centaur orienting to release Amazon's Project Kuiper satellites to build their low Earth orbit satellite broadband network.
$140.
Launch enabled.
$137. FTS armed.
T-minus 90 seconds. The launch vehicle, ground systems, payload, and Eastern Range are go for launch.
For those of you just joining us, I'm Britt Porcelli here with Ryan Schleter for today's live coverage of ULA's Atlas V launch of Amazon Project Kuiper satellites.
At this time, the team is not working any issues, and we're proceeding towards liftoff at 8:09:30 a.m. Eastern Time.
T-minus 1 minute.
Rock, report range status.
Range green. $40. Stable at step 3.
Verify ECS reduced for launch.
Verified. 25.
Status check.
Go Atlas. Go Centaur.
Go Kuiper.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition. 1. And liftoff of the United Launch Alliance Atlas V rocket, carrying 27 satellites for Amazon's Project Kuiper Internet constellation. Continuing a new chapter in low Earth orbit satellite connectivity.
U is on closed loop control. Engaging our first throttle segment. And completed pitch program.
You are hearing Sarah Bailey Glasgow providing launch vehicle ascent
operated
data.
as expected. Hydraulics look good. Successfully completed roll program. Body rates are continue to look good. Mach 1, Atlas V is now supersonic. Throttling up as expected. Vehicle is now 5 miles in altitude, 2 miles down range, continues to move down the center of the range track. Booster engine operating nominally. Now passing 1 minute into flight. Body rates are nominal. Engine continues to operate as expected. Throttling down, engine continues to burn normally. Vehicle is now moving at 2,700 miles an hour down the center of the range track. Vehicle is now 1/2 of its liftoff weight. Max Q passing through maximum dynamic pressure. And we have good indication of SRB burnout coming up on SRB jettison. Throttling up as expected. And we have good indication of separation of all 5 SRBs. Engine continues to burn normally. Vehicle is now on closed loop steering. Engine operating parameters look good.
We just heard confirmation of solid rocket booster jettison. These additional motors augmented the thrust at liftoff to give the Atlas rocket an extra boost to punch through the thicker parts of the atmosphere.
And speaking of punches, these SRBs provide 350,000 pounds of thrust each. So with 5 GEM 63s combined with the RD-180s, you get 2.7 million pounds of total thrust at liftoff. Talk about some firepower.
We're now coming up on our next mission event, jettison of the payload fairing. Let's listen in.
Atlas is now 80 miles downrange, moving at 5,600 miles an hour. Holding acceleration at 2.5 Gs in preparation for payload fairing jettison. And vehicle has passed the Kármán line. We have exited Earth's atmosphere. Atlas is now 1/4 of its liftoff weight. And Centaur reaction control system is pressurizing to flight levels as expected. And we have good indication of payload fairing jettison and CFLR deck jettison. Engine continues to burn normally.
Flight commentator Sarah Bailey Glasgow just called out confirmation of the payload fairing jettison. The composite fairing protects the spacecraft as it pushes through the harshest parts of Earth's atmosphere. Next, we'll hear callouts for the cutoff of Atlas's first stage engine and the separation of the booster stage, followed by the ignition of ULA Centaur's second stage engine.
These events occur when the first stage has escaped Earth's atmosphere, getting above the Kármán line and into space. The Centaur upper stage, with the Kuiper satellites attached, then takes over on a trajectory to a precise orbit in space. Let's listen in as we approach these milestones.
Engine continues to burn as expected. 30 seconds to BECO. Boost base chill down in progress. Temperatures are operating as expected. Body rates continue to look good. PU has gone to open loop control as expected. Boost phase chill down complete. Temperatures operated as expected. And we have good indication of booster engine cutoff. And stage separation. Pre-start on fuel and locks, good staging. Ignition, and full thrust. RL10 is running nominally. This will be just under 13-minute first burn. Steering has been enabled. and PU system has gone to fixed angles as expected.
This is Atlas Mission Control at T+4 minutes and 59 seconds. We just heard flight commentator Sarah Bailey Glasgow confirm the successful completion of the early milestones in today's flight, and all systems continue to operate nominally. So we had a really great launch today. We went at the beginning of our window, which is always a plus. The line stayed pretty light, not a lot of chatter. Our engineers, best in the world, kept forward, and we were able to have a successful early milestones of today's Atlas Kuiper 3 launch.
Yeah, it was great to see. The 551 is always a special rocket. The bruiser configuration, as we lovingly call it, with those 5 extra SRBs, 2.7 million pounds of thrust, it really just leaps off the pad. As we wrap up our live coverage, we want to say thank you for tuning in for today's flight and remind you to visit ulalaunch.com, follow our socials at ulalaunch, and subscribe to our YouTube channel for future live streams, launch highlights, and behind-the-scenes rocket content. Also, plan to join us next month for another Atlas V launch. Before we sign off, let's take another look at today's liftoff.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition, 1. And liftoff of the United Launch Alliance Atlas V rocket, carrying 27 satellites for Amazon's Project Kuiper Internet constellation. Continuing a new chapter in low Earth orbit satellite connectivity.
U is on closed loop control. Engaging our first throttle segment. And completed pitch program.
You are hearing Sarah Bailey Glasgow providing launch vehicle ascent data.